Alright, ladies and gentlemen, welcome back to my YouTube channel, and this is Kasalikan Vlogs. And today we'll be focusing on hints for verifying trigonometric identities. So ladies and gentlemen, tune in because I'll be teaching you on how to prove or verify trigonometric identities. So here are the hints for verifying identities. First is learn the fundamental identities. Also be aware of equivalent forms of fundamental identities. So take note of these fundamental identities, reciprocal identities, quotient identities, and Pythagorean identities, because this will be used as we are going to take with this verifying identities or proving identities. So take note of these fundamental identities. Second hint is that try to rewrite the more complicated side of the equation. So we need to choose the complicated side, as we're going to move that one, or we're going to prove that one to the left or to the right side, as long as we have to rewrite the more complicated side. And number 3, it is sometimes helpful to express all trigonometric functions in equation in terms of sine and cosine. So if we are not familiar with some of the trigonometric identities, so it's better to equate all those trigonometric functions into equation in terms of sine and cosine. Next is, usually any factoring or indicated algebraic operations should be performed. So take note, I'll be presenting to you most of algebraic identities that we'll be using during this verifying trigonometric identities. So take note of these algebraic identities. So we have here, I presented 5 algebraic identities, so please familiarize this one. And for example, the expression sine squared x plus 2 sine x plus 1, we could factor that one as sine x plus 1 quantity squared. So take note of that, because these algebraic identities are very useful in our verifying trigonometric identities. So now, number 5, as you select substitutions, keep in mind the side you are not changing because it represents your goal. If you are changing the right side, so your goal is your left side. If you are changing your left side, your goal is your right side. So if an expression contains 1 plus sine x, so we need to multiply both numerator and denominator by 1 minus sine x would give 1 minus sine squared x, which could be replaced with cosine squared x. So take note, because if we're going to multiply here 1 plus sine x in both denominator and numerator, so still this is equal to 1, and it would not affect when a number is multiplied by 1. Alright, so that's all about the hints for verifying trigonometric identities. So quotient, the procedure for verifying identities, is not the same as that of solving equations. So technique used in solving equations, such as adding the same term to its side and multiplying each side by the same term, should not be used when working with identities. So take note of that. So hindi lahat ng panahon we could make use of algebraic functions or algebraic concept. At this time, we could not multiply both sides, but we have to multiply it by 1 plus sine x over 1 plus sine x, because that is equal to 1 still. But we could not add or subtract both sides, and we could not cross multiply when we're going to verify identities. So if we're going to change the left, only the left, or change the right, or both sides will be changed without adding both sides or each term and multiplying each term by the same term, or cross multiplication. It's not allowed here. Alright, so that's the quotient. So to avoid the temptation to use algebraic properties of equations to verify identities, so one strategy is to work with only one side and rewrite it to match the other side. So that's why we could work with the more complicated equations. So we have to, our target could be, if the more complicated is the right, so there the target is the left. And that's it. So we have here verified each trigonometric equation is an identity. So I have here 8 identity that we need to verify today. So take note of that. So I guess this is a very common. I selected common identities that might come up during your examination. Alright, so let's proceed with number 1. So 1 cos x over 1 minus sine x is equal to 1 plus sine x over cos x. So this is hint number 6 that we need to multiply. If we could say that 1 plus sine x, we can multiply it by its 1 minus sine x. So we have here, if we have to verify, we need to change. If our goal is this part, so we have to change this part. So if we're going to change this part, this is 1 plus sine x over cos x. You're going to multiply it by 1 minus sine x over 1 minus sine x. That is hint number 6. So that is equal to, our goal is this part. This is our goal. So 1 plus sine x, 1 minus sine x, this is in the form of a minus b, a plus b. So that is a squared minus b squared. So take note of this identity. So therefore we have here 1 minus sine squared x over cos x, 1 minus sine x. So that's it. So if we're going to rewrite this one, so this is an identity, so still we could have this one as cos squared x plus sine squared x is equal to 1. So therefore cos squared x is equal to 1 minus sine squared x. So this is the identity, so therefore we have here, this is cos squared x over cos x times 1 minus sine x. So cancel here 1 here. So therefore we have cos x over 1 minus sine x is the same with this one, cos x over 1 minus sine x. So therefore they are now the same. So we have now verified number 1, that cos x over 1 minus sine x is equal to cos x 1 minus sine x. That's it for number 1. So let's proceed with number 2. So this is in the form of factoring. So if we're going to factor this one in number 2, so we need to verify this one because this is the more complicated part. This is complicated compared here. So if we're going to factor this one, this is the same as in algebra that we have to factor like this. So this is in the form of a squared plus b squared times a squared minus b squared is equal to a raised to 4 minus b raised to 4. This is in the form of this identity. Okay, so since this is a factor, so we have here sine squared x plus cos squared x times sine squared x minus cos squared x is equal to 2 sine squared x minus 1. So sine squared x plus cos squared x, this is an identity which is equal to 1. So therefore the remaining is sine squared x minus cos squared x is equal to 2 sine squared x minus 1. So we could use identity for this one. So the identity for this one is sine squared x minus 1 minus sine squared x. This is the identity, is equal to 2 sine squared x minus 1. So sine squared x minus 1 distribute plus sine squared x is equal to 2 sine squared x minus 1. So sine squared x and sine squared x, it is 2 sine squared x. This negative minus 1 is equal to 2 sine squared x minus 1. So therefore, we proved already and verified that this is an identity. That's number 2. So let's proceed with number 3. So in number 3, so we have here the concept of least common denominator. So this is the form. So we have to find the LCD for this one, and this is the more complicated part, so therefore we have to prove, and this is our goal. Our goal is 2 sec x. So 1 plus sine x times cos x. So therefore we have here multiply divided by the remaining is cos times cos is cos squared x, plus when you divide here, divide this cos x, the remaining is 1 plus sine x times 1 plus sine x. So therefore 1 plus sine x squared. That is, our goal is 2 sec x. So now we have to expand this part. So if you're going to expand this part, this is in the form of a plus b squared is equal to a squared plus 2ab plus b squared. So therefore we have here cos squared x plus a squared, that is 1, plus the product of a and b, if this is our b, twice to 2 sine x plus sine squared x over 1 plus sine x times cos x. That is equal to 2 sec x. So this is, if we're going to have this part combine here, so this is equal to sine squared x plus cos squared x plus 1 plus 2 sine x over 1 plus sine x, and we have here cos x. Our goal is 2 sec x. So sine squared, this is an identity that's equal to 1. So therefore we have 1 plus 1 plus 2 sine x over 1 plus sine x times cos x is equal to 2 sec x. So 2 plus 2 sine x over 1 plus sine x times cos x is equal to 2 sec x. So we can factor this one as 2. 1 plus sine x over 1 plus sine x, we have here cos x is equal to 2 sec x. So cancel this part. So 2 over cos x is equal to 2 sec x. So therefore cosec. So remember cosec. So therefore the inverse of this one is 2 sec x is equal to 2 sec x. So remember cosec. Okay, so we have proved this part. So this is an identity. So that's number 3. So number 4, we have sec a plus cosecant a and sine a plus cos a is equal to sec a cosecant a. So first is what we're going to do is we're going to rewrite all this one in the form of sine and cosine. So we have here 1 over cos a plus cosecant is 1 over sine a over sine a plus cos a is equal to sec a cosecant a. So we have to take the LCD of this part. So we have your cos a plus sine a times sine a. So therefore this is sine a plus this one divided by cos. So the remaining is sine, and this one divided by this part sine a. The remaining is cos a. This is a rather. So this is not here. So this is over sine a plus cos a is equal to sec a and cosecant a. So we have here, if we're going to take the reciprocal, so sine a plus cos a over cos a sine A times the reciprocal, it is 1 over sine A plus cos A equals sec A and cosecant A. So now we have to cancel this part. So the remaining is 1 over cosine A sine A is equal to sec A cosecant A. So we could regroup this one as 1 over cosine A and 1 over sine A equals sec A cosecant A. So the value for 1 over cosine A is sec A, and this is sec A, times 1 over sine is cosecant A. So therefore we have here an identity. So we have here sec A cosecant A is equal to sec A cosecant A. So check. So therefore, this is an identity. So that's number 4. So let's have number 5. So number 5, so the first thing that we're going to do when we cannot find any identity to this part is when we need to express all those terms in terms of sine and cosine. So we have here sine x over cos x minus 1 over sine x okay, so sine x, this is 1 over sine x, okay, sine x times 1 over cos x because cosec, and we're going to distribute this part, so minus, this will become plus 2 cosine squared x times 1 over sine x times 1 over cosine x. I changed it already because this is the value, right? And this is the value when you're going to distribute here. This will become 1 here, this 1, and we are going to distribute here. This is the result, is equal to cot x. Alright, so we have here cos, I cancel this part. So the remaining is sine x over cos x minus 1 over sine x cos x plus 2 cosine x over sine x is equal to cot x. So sine and cosine, here cos and sine. So we have to find an LCD of here. So the LCD is sine x cos x, so that we could combine these all terms. So divided here, the result is sine squared x minus 1, and when you're going to divide here, the result is plus 2 cosine squared x is equal to cot x. Alright, so we have here sine squared x. We could rearrange this one as negative 1 minus sine squared x. We have to extract the negative. So 1 minus sine squared x is equal to cos squared x. So negative cos squared x. So if we're going to write this part, this is negative cos squared x plus 2 cos squared x over sine x cos x is equal to cot x. Alright, so we are going to copy here. So the remaining is here is equal to cos squared x over sine x cos x only is equal to cot x. So cancel 1 cos. So therefore, cos sine x over sine x is equal to cot x. So cos over sine, that is cot x, is equal to cot x. So this is an identity, number 5. So number 6, tan x plus cot x is equal to sec x and cosecant x. So we have here the solution. So we have to express all these terms by sine and cosine plus cosine x over sine x is equal to sec x cosecant x. So this is our goal. So we have to combine. So we have here cos x sine x divide here. The remaining is sine squared x divide then multiply by sine, that is sine squared x, plus divide, the remaining is cos squared x. So sec x cosecant x. So we have here the identity which is equal to 1. So 1 over cos x sine x is equal to sec x cosecant x. So we could regroup this one as 1 over cos x times 1 over sine x is equal to sec x cosecant x. So we have here 1 over cos is sec, so sec x here, and 1 over sine is cosecant x. So therefore we have sec x cosecant x. So prove the identity. So therefore number 6 is an identity. So number 7, sec y tan y over cos y plus cot y is equal to sec y tan y. So one thing that we're going to do again is we're going to express all these terms by cosine and sine. 1 over cos y plus sine y over cos y over, this is equal, cos y plus cosine y over sine y is equal to sec y tan y. So we have to find the LCD. So the LCD of this part is cos y, and this is 1 plus sine y over equals, and this the LCD of this one is sine y. So therefore we have here cos y sine y plus cos y. Alright, because sine y divided by sine y, the result is sine is equal to 1 times cos y, the result is cos y is equal to sec y tan y. Okay, so we have to take the reciprocal of this part. So 1 plus sine y over cos y times the reciprocal is sine y over cos y sine y plus cos y equals sec y tan y. So we have to factor this part. This is sine cos here, cos y. The result is sine y plus 1. So the remaining here is cos. So therefore we could cancel this part because 1 sine y plus 1 is same as 1 plus sine y. So therefore 1 over cos y times sine y, the remaining is cos y, is equal to sec y tan y. So 1 over cos is equal to secant y, and sine over cosine is tangent y is equal to secant y tangent y. So prove that this is an identity. So that's all about number 7. So number 8 is sec x plus tan x over sec x minus tan x is equal to 1 plus 2 sine x plus sine squared x over cosine squared x. Okay, so as I remembered, I presented here, we could move left or right, right or left, or we could move both, or we could change both. At this time, I'll be teaching you on how to change both. So the previous example is I'm changing the right or changing the left. So we are having the target. And this time, we have to move left and right simultaneously. Alright. So in this case, we have here 1 over cos x plus sine x over cos x over 1 over cos x minus sine x over cos x. So I have to move this part. This is an identity which is a plus b squared. So a plus b squared is equal to a squared plus 2ab plus b squared. So this is the identity for this part here. So therefore, we can have this one as 1 plus the b here is sine x squared over cosine squared x. Okay, so now same here. So the LCD of this part is cos x. So cos x, this is 1 plus sine x all over here, and this is cos x. So 1 minus sine x. So we could cancel this part because if we're going to take the reciprocal, so still that could be cancelled. And we have here 1 plus sine x squared over, this is an identity which is 1 minus sine squared x. So we have to copy here 1 plus sine x over 1 minus sine x equals 1 plus sine x quantity squared over, this is factorable, so 1 plus sine x and 1 minus sine x. So we have here cancel this part 1 here. So therefore 1 plus sine x over 1 minus sine x is equal to 1 plus sine x over 1 minus sine x. So proof. So I'm moving or changing both left or right. So this is an identity. So previously I just moved left or right, but commonly, so we have to move what is the more complicated part, because if I'm using this number 8 as an example, if we're going to move both sides, it's quite long. So just stay for rewriting for the more complicated part, because still that is part of verifying identity. So that's all about our problem. We have here 8 problems. So let's proceed now to try this. Try this, verify the following identities. So sec theta plus tan theta quantity squared is equal to 1 plus sine theta over 1 minus sine theta. And 1 over cos squared x minus sine squared x quantity squared minus 4 tangent squared x over 1 plus tangent squared x quantity squared is equal to 1. So verify this identity. So I'll just leave the link here for more information about the free load. So just go with the link here on how to apply for the preload. So thank you so much for tuning into this channel, and I hope everyone that you have gained hints on how to verify identities. God bless everyone, and see you for more videos to come. Thank you and God bless.